Okay, so here we are on our examples. We're going to do 4 examples, and for all of them we want to do these things. We want to find the center, vertices, foci, asymptotes, and graph. Yes, I did include this. I know in the last video I said I was not going to at the top because it takes up space, but it's there anyway. It's good for our reference. So here we go. The first one that we're going to do this for is y squared over 36 minus x squared over 4 equals 1. All right. First thing I want you all to notice is the fact that our y is positive. So that means that we're only going to have curves in the y direction, or opening up and down. So the curve is going to open in the y direction just because y is positive. Okay? So we're going to do the same thing we did with ellipses. We want to graph it first so that we can extract all the information that we need from the graph. So let's draw a graph here. I'm going to draw a nice big graph so that make sure I have enough room here. So there's x, there's y. Okay, so here we go. We want to start the same exact way that we did with our ellipses. So we want to write the bottom numbers in terms of something squared, because that's going to tell us how many units we're going in each direction from the center. So I think we all can agree that 36 is the same thing as 6 squared, and 4 is the same thing as 2 squared. Okay, I'm going to circle just like I did yesterday. Circle, circle, and we have nothing being added to or subtracted from the x or the y, so our center is again at 0, 0. So let's put the center there. Because we have a 6 directly underneath the y, that means we're going 1, 2, 3, 4, 5, 6 in the y direction, 1, 2, 3, 4, 5, 6 in the y direction each, and then we're going 2 in the x direction. So 2 to the left and 2 to the right. Now here's where it changes. Remember, we don't have a curve that goes together because we have a minus. We have a hyperbola here. So what we want to do is we want to draw a dotted line through each of these points. Okay, so here we go. So we're drawing dotted lines. We're actually going to construct a box. Okay. Once we have our box constructed, what we do next is we actually want to connect the diagonals together. Okay, what we're doing is we're forming our asymptotes. So here we go. There's the diagonal this way. So that's one of the asymptotes. And same thing in the opposite direction. Here we go. Okay, so that's good. And now for the actual curve itself. Remember it says that y is positive so that it opens up and down. So the 2 points that we have here that are in the y direction, the ones that we went up and down from y, those are going to be our vertices. Okay, so we're going to draw our curve through there, and we're going to get very close to these asymptotes, but not actually touch the asymptotes. Okay, so I can now move this up. Okay, so there's one. There's the bottom half of the curve, and the other one is up here. Sorry, I know I'm kind of running into the denotation for the y-axis, but there's our curve. Okay? Now, so that's the graph. We did one part of it. We want to find the center. Because, again, nothing's being added to or subtracted from x, the center is at 0, 0. And let's see, vertices. So the vertices here, the vertices are 0, 6, and 0, negative 6. So they're only the points that the curves change inflection at. And let's see, what else do we want? Center, vertices, graph, foci, and asymptote. So remember, these foci are out here somewhere. We don't know where specifically, but they're out there. Now, I didn't say it in the last, in the key terms piece. I forgot to include it in there. But just like the relationship between the center of the ellipse and the foci with c squared equals a squared minus b squared, here we're back to what we're used to with this Pythagorean theorem. Okay, so for the foci, c squared equals a squared plus b squared, and c represents the distance from the center to the foci. So we did talk about that in the last one. So c is the distance from the center to foci. Okay, so the a and the b are here and here. It doesn't really matter now which is which, because we're adding them together and they're both positive, they're distances. So we have 6 squared plus 2 squared. So 36 plus 4 is 40. So c squared equals 40. Let's put that down here. C squared equals 40. I know that I'm kind of heading off the paper here. So we do the opposite, take square root, so c equals the square root of 40, and we want to make sure that we simplify this. So this is where we either do a factor tree or we look for perfect squares. So if I do the perfect squares way, I know that the square root of 40 is the same thing as the square root of 4 times the square root of 10, and the square root of 4 is 2, so it's 2 root 10. So again, that distance, what that's saying is the foci are 2 times the square root of 10 away from the center of the ellipse, of the center of the hyperbola. So the way we write the coordinates are, since it's opening in the y direction, 0, comma, plus or minus 2 root 10. Okay, and plus or minus because we have, this is the positive one and this one is the negative one down here. Okay, the last piece is the asymptotes, the equation of the asymptotes. And for this one, we're looking for, remember that, let me pull this back down one more time, the asymptotes are these lines. So typically we need a slope and a y-intercept to be able to have an equation of a line. So in this, we notice that the slope is, we always remember slope is rise over run, so we went up 1, 2, 3, 4, 5, 6 and right 2. So up 6 and right 2. So y equals 6 divided by 2 times x, that gives us our slope. Whoops, make sure you guys can see that. And then the y-intercept, again, it intercepts the y-axis at 0. So it's 6 over 2x plus 0, or 3x. And then the other one is going in same slope but in the opposite direction. So we can just say plus or minus 3x. Okay? So now we did all of those things. So are there I almost did it again. Almost did questions. You're not here, so never mind. Questions in the margin, and we will answer them tomorrow during class. All right? Let's move on to the next example. All right. So this one we've got 16x squared minus 4y squared equals 64. So we want to get this one into standard form first. So let's do that. Divide by 64, everything. And we're going to move through this one a little bit quicker, okay? So when we reduce all of these fractions, we get 16 over 64 is 1 over 4. 4 over 64 is 1 over 16. And then we have 1 over here. So notice now that the x is first. It doesn't make a difference, again, whether it's first or second. But if it's positive, then that means the curve opens in that direction. Because the x is positive, that means the curve opens in the x direction. Okay, so let's draw this in terms of numbers squared. So 4 is the same thing as 2 squared, and 16 is the same thing as 4 squared. So let's circle these, because again, that'll tell us how many units we're going in each direction. Let's go ahead and draw a graph over here. This one's a little better. It's not going quite as far of a distance in each one. Okay, so we have nothing being added to or subtracted from the x, so that means x or y. So our center is at 0, 0. There's a 2 directly underneath the x, so we're going 2 units to the right, 2 units to the left, putting dots on each of those. And then there's a 4 underneath the y, so that means we're going up 4 units and down 1, 2, 3, 4 units. And again, this is where instead of connecting them with an oval or an ellipse, we want to draw a box through all 4 of those points that we just put on the graph. So everybody draw a dotted box. And the reason that we make it dotted is because it's not actually part of the graph. It's part of what we use to construct the graph, but it's not part of the graph itself. So next step, remember, is we connect the corners of the box with diagonals. So connect the corner with diagonals. Those are our asymptotes. Okay, and now, again, because the curve opens in the x, that means those two are our vertices, because those are in the horizontal direction or on the x-axis. So we draw our curve very close to the asymptotes, but not actually touching. So for both of these, very close to the asymptotes, but not actually touching. And make sure that you don't make your curves go back toward the other direction. That's not mathematically accurate. Okay, so here we go. Center, nothing. We already said center is 0, 0. And then vertices. So our vertices on this are here and here. So that's a vertex. And on the other side, that's a vertex as well. That coordinate is 2, 0, and the one on the other side is -2, 0. What next? Let's do the foci next. So c squared equals a squared plus b squared. So we have a and b are 2 and 4. So c squared equals 2 squared. Oops, I just realized. I'm sorry about that, you guys. I just realized that I'm off the paper. Okay. So c squared equals 2 squared plus 4 squared. Again, these are a and b. So c squared is 4 plus 16, which is 20. And then opposite of squaring is square root. So c equals the square root of 20. And again, I want to look for perfect squares or do a factor tree, whichever one you're more comfortable with. I know that 20 is 4 times 5 and that the square root of 4 is 2. So it's 2 root 5. So that means foci right now are on the x-axis. Okay, so the foci only exist wherever the curve exists. And so we actually write these as, this one would be 2 root 5, comma 0, and the other one is -2 root 5, comma 0. So in the last problem, we actually wrote it all as one piece, and that's totally fine too. In other words, plus or minus 2 root 5, comma 0. Okay, asymptotes. Asymptotes, we've got, again, if we look at our graph, we need a slope and a y-intercept. So y-intercept is 0 and the slope is rise over run, or 1, 2, 3, 4 over 2. So it's 4 over 2x plus 0. Sorry about that. Let me move it up again. 4 over 2x plus 0, or 2x. So that goes for the one that's in the positive direction, or this one. The other one is exactly the same, it's just the slope is negative. So y equals 2x and -2x. Those are our asymptotes. Okay, I'm going to go ahead and stop this video. I'm going to move on. There are 2 more examples that we have to go through. Actually, there's just one more. Let me see if I can fit it in. No, I'm actually going to stop. Okay, so one more video. Sorry, this one's a little bit longer, guys, but I promise this is actually the last one before we take a little break and do some conic artwork and graphs, and then we'll be good. Okay, so just switch over real quick and we'll be done shortly, I promise.